Well, good evening, folks. Papa D coming to you tonight again from Central Florida. This is David Delivers Space. And welcome again to all of our existing viewers, our existing subscribers, and if you're a new subscriber, welcome to the family. We are a channel that loves all things space, but we do a lot of streaming and following of various launches coming out of the Cape, of course, because we are here in Florida. But this evening's launch, albeit another Starlink launch, as you saw by the header, it's Starlink 17-14. It is a Falcon 9 Block 5, of course. This is a launch that's taking place out of the West Coast this evening. Coming off of, trying to make sure I've got all my pages lined up, and it looks like I do. Okay, sorry about that. We are got to make sure we're all lined up. But we're launching off a Slick 4E out at Vandenberg this evening. Looking at approximately about 3.5 minutes. I'm going to bring up my feed at this time and see. We do not have a feed yet from SpaceX, so they are not ready to go live. Let me check the times also. Originally the time was scheduled for 10:45, moved to 10:56, and it just moved again. We're up to 11:23, so it looks like we're going to have a launch window between 11:23 ends at 2 a.m. So what we'll probably do is shut the stream down for now and reinitialize after the delay has passed, or we'll just keep this stream live and come back up when we get it go. But it looks like right now we're only about 30 minutes out. So we'll stay live here for a bit, make sure the time doesn't move. We're looking at a T0 right now at about 29 minutes. But again, this is Starlink Group 17-14. It's carrying 24 Starlink version 2 satellites. Of course, the V3s are not yet available to be flown, at least in any kind of serious quantity at all, because of the need for Starship, which we are looking at hopefully a launch date being set for our next Starlink launch shortly. We can talk more about that. But this is again, Falcon 9 Block 5, 24 will be the total payload. We're looking at a booster, a reused booster, of course, B1100. This is its 5th flight with a 33-day turnaround time. It is scheduled for recovery. And that's going to be, again, we're launching from Vandenberg, so this will be off the west coast. This will be scheduled to be received back by, of course, I Still Love You, the automated drone ship, the recovery ship. So we are expecting, hopefully, to have the video of that also. I'm going to take a quick second, though, to thank a few people. Number one, our subscribers. Those of you that have stuck by us, we are starting to ramp things up on our 2 channels, and we are at this point in time with the launch cadences coming out of the Cape alone before Starship starts to really blow and go out there. We are going to be quite busy, to say the least, trying to pick up as many of these launches as we possibly can. Right now, again, the cadence is picking up. We're looking at just this week alone. But we do have an Electron taking off out of New Zealand that we're going to try to cover. That's going to be about 11:09. So we are right up against that because of our time push on the Starlink. So we may have to try to switch over to that for just a bit. I'll try to confirm that and switch over. But we also have a a couple of Chinese long marches coming off, a Progress ship, delivery ship out of Kazakhstan, destined, of course, for the International Space Station, and then another Starlink a little bit closer to the end of the month, around that's 26th. So there's a whole lot going on, and we do see, it's good to see the electrons coming into the fray, jumping in there a little bit. But we are going to keep as close eye on those as we possibly can. That's an exciting company, a lot of things going on there. We got to do a video about that. But right now we're holding at about, bring me back up here, about 25, 26 minutes for the Starlink launch. What I'm going to do is I'm going to stand by for just a second, see if I can bring up the feed for Electron before it goes live, and maybe we can piggyback these two launches right up against themselves. And I planned on bringing up a separate feed for that, but of course the delay for Starlink, the Starlink launches impacted that. So let's stand by for Papa just for a second. I'm going to bring up my other feed, and we're going to turn this into a double header stream if possible. So stand by, guys, and I will be right back. Alright folks, about ready to bring up the feed so we can watch the launch of the Electron. Going to be Kakushin Rising. That is a RocketLab launch scheduled to go off in about 9 minutes or so. So let me patch that feed over to you guys, and we will pick up some speed here on what the launch is and what we've got leading up into and back to, hopefully, the Starlink launch. So let's bring up our live feed, and again, thank you to RocketLab for being so kind to provide these feeds and allowing the media to access and share all their amazing launches and what they do out there with the rest of the world and our viewers.
Power their own sets of Rutherford engines. Now, Stage 2 contains a single Rutherford engine, while Stage 1 holds 9 engines to generate enough thrust to power Electron most of the way to space. Each one of those engines are 3D printed, and they're also unique in the industry for being electrically driven, using battery-powered pumps rather than traditional gas generator turbo pumps. That design makes the Rutherford more efficient for mass manufacturing, which, along with Electron's flight history and satellite deployment accuracy, are some of the key reasons why Electron is the world's most frequently launched small orbital rocket.
Our heritage in propulsion is one we're particularly proud of here at RocketLab. As well as the Rutherford and Curie engines used on Electron, we've also created a significantly larger and more powerful rocket engine called Archimedes, designed for our much larger, different class of rocket, Neutron. Just to give you a sense of scale, Archimedes has roughly 35 times the thrust of a Rutherford engine, while a single Archimedes is equivalent to more than 3 entire Electron rockets.
Now, on the other end of that spectrum is our newly introduced electric propulsion system for satellites called Gauss. And it's made for long-duration missions in space and high-performance maneuvering aimed at new satellite constellations. These types of thrusters are hard to find or to bulk order in the satellite industry, but with Gauss firing away and a production line already set up at our facilities, that is something we're looking to change. Here's more about Gauss.
Gauss opens a new chapter in propulsion at RocketLab, but it really is a natural extension. And electric propulsion is an important tool to have in the kit. Propulsion is in our DNA. I think RocketLab has one of the best propulsion teams in the entire world, and it's really exciting to see it expand into electric propulsion. Gauss is an electric propulsion system based on a Hall effect thruster that's designed to do orbit raising and deorbit, as well as on-orbit station keeping for constellations. So there have been a lot of bottlenecks in the supply chain for constellation programs, whether it's commercial or national security, and one of the biggest has been electric propulsion. We experienced that in many of our programs, and so we decided to insource and solve the problem ourselves. So Gauss is a really good thruster in its class, and so it's about a 700 to 850 watt thruster that's got about 40 millinewtons thrust performance and excellent specific impulse. But what's great about it is that it's also throttleable, so that you don't have to size your power system to the propulsion, but rather you can have the propulsion work to your power system. Even though we've qualified it for xenon, we of course recognize that there's other gases that people want to fly. So Gauss was designed with that in mind as well. Like Pete has said about our rockets, the first rocket's the easy one. It's the 10th one that's hard, and we've established high volume production capacity to deliver units now. RocketLab's initial production capacity is about 200 units per year, and that includes the Hall effect thruster itself, as well as the flow control and the high voltage power and processing unit avionics that drive the system. And so because RocketLab produces the Gauss system in New Zealand, it is actually subject to no U.S. export restrictions. And so this is a really important factor that particularly international customers are going to consider when they make their electric propulsion selections. It's a really exciting moment for RocketLab. We've started to deliver units to ourselves. And so right in this factory, we have satellites being integrated with our Gauss thrusters and available for the market today.
With the introduction of our Gauss thruster, we are continuing to alleviate the pain points of satellite production.
We're now just inside 4 minutes to launch, and everything that you're seeing here is about to become fully automated for the final countdown before liftoff. Electron's onboard computers will take control of the terminal count from T-minus 2 minutes, and will begin to manage thousands of checks per second to make sure Electron is ready for launch. At that point in the countdown, both stages will also be fully fueled with liquid oxygen and kerosene. The propellant tanks are being kept at precise pressure and temperature before we reach liftoff, and you'll hear a couple of callouts from operators in mission control that relate to those checks as well. You'll also notice some venting from Electron while that countdown continues, which is completely normal up until the system is fully pressed for flight within a minute of liftoff.
Then from 20 seconds and counting, final checks are complete. The launch director will count down to launch from T-minus 10 seconds, and then at T-minus 2 seconds, Electron's engines will ignite right on time for liftoff at T0. We're going to raise the volume now on mission control and listen into all of that take place. Go Kakushin Rising, go JAXA, and go Electron.
Beacon, lock the auto sequence and confirm.
Locked.
Copy and confirm all flight computer ASGOs are green.
All flight computer ASGOs are green.
Copy, Beacon. We'll go for auto sequence start at T-minus 2 minutes. LDs go for launch.
All right, folks, as you can see, we are within inside of 4 minutes until launch of Kakushin Rising. And just real quick, because we came in late to the game on this, this is a Waseda Sat-02. It was produced by Waseda University, manufactured by Waseda University, and it is a technology demonstrator. It is a 3D printed satellite.
The vehicle is fully on internal power. AFTS is green and enabled for flight.
And it will be used to conduct some experiments regarding deployment of membrane surfaces. So it's a demonstrator model, it's a demonstrator project, and pretty fascinating. It's a 3D printed satellite. It's going to be just a single payload, about 1.2 kilograms on this single piece of equipment today.
LOX load is complete. The system is in recirculation.
All right, everything does look good, and we do have a T0 getting ready to go internal on the rocket. So I'm just going to switch back over to the commentary and let you all enjoy this.
Anti-gravity is disabled.
Once we get ready to get through the majority of this, we'll switch back over, hopefully, to the SpaceX launch.
Stage 1 and Stage 2 tanks are pressed
Looks
for
to
flight.
be about 14 minutes out at 11:23.
High flow engine purge enabled.
So enjoy the launch of Kakushin, yeah, Rising. This is RocketLab, the Electron delivery vehicle.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
And we have liftoff.
Beginning control.
Kakushin Rising, Electron by RocketLab.
Stage 1 propulsion is nominal.
Liftoff confirmed, and Kakushin is rising with Electron from Launch Complex 1. We are on our way to orbit for JAXA, and pitchover has begun to place the launch vehicle on its correct trajectory south over Antarctica.
We're building up horizontal velocity now before Electron is expected to pass through max Q, or maximum aerodynamic pressure, sorry. We should hear a call out from mission control that we've cleared it momentarily.
Cleared max Q.
And there's the call out for Max Q. Those 9 Rutherford engines have accelerated Electron past 2,200 kilometers an hour and more than 18 kilometers above Earth, now just a minute and 30 seconds after liftoff. Next up for the rocket will be main engine cutoff, otherwise known as MECO.
With Electron's boost through Earth's atmosphere almost complete, the first stage's role in this mission is wrapping up since the engines have chewed through most of their fuel supply. The Rutherford engines will soon shut down completely, which will allow the rocket's second stage to separate. With a bit of distance between them, the second stage's sole Rutherford engine will then ignite to carry on the mission's momentum to orbit. And those events occur as MECO, stage separation, and second stage engine startup, all of which we can expect to hear from our operators again soon in Mission Control.
"15 seconds to staging."
Enter it burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
Beautiful work. That is MECO, stage sep, and second stage engine ignition as expected as Kakushin Rising continues on to orbit. And in just a few seconds, Electron's payload fairing will split and fall away in 2 halves. That will be the first time that Kakushin Rising will be exposed to space.
Fairing separation confirmed.
A nice clean payload fairing jettison there, and another Electron launch milestone complete. Electron's second stage is cruising along nicely at more than 8,700 kilometers an hour, now 125 kilometers above Earth on its way to its 540 kilometer circular orbit. We have a few minutes until our next event for Electron, which is battery hot swap maneuver that takes place for the Stage 2 Rutherford engine. That's scheduled to happen at approximately 6.5 minutes into this mission.
Electron's second stage engine burn continues nominally for Kakushin Rising, with this phase of the mission focused entirely on building orbital velocity before those satellites are released. Guidance systems are steering Electron with precision toward the mission's 540-kilometer target orbit. All right, our mission control operators are closely monitoring the vehicle's performance in the lead up to the second stage's battery hot swap event. So the Rutherford engine relies on batteries to drive its electric propellant pumps. But as the second stage burns through the original battery's power, it must transition to a fresh set of batteries mid-flight to keep the engine burning to full duration. And that's why the maneuver is called the battery hot swap, since it takes place right in the middle of that propulsion phase.
The old batteries will be jettisoned, which you should be able to see in real time on your screen. Just watch for the silver box to eject quickly, right at around the T plus 6 minute 33 second mark. Just a couple of seconds to go until that happens.
HVV discharge holding nominal, approaching a hot swap in roughly 30 seconds.
shutting down.
All right, folks, for those of you just joining us, we were initially going live for the Starlink Group 1714 launch. That got pushed back. Right now we are watching the Kakushin rising. Wasita
Battery
Sat
hot swap
02.
confirmed, and the second stage is powering on beautifully for JAXA and Kakushin rising. We got another 2 minutes or so of Rutherford engine burn time to get us to the mission's transfer orbit. And at this point in the flight, Electron's second stage has completed almost all of its mission milestones.
The last remaining steps are second stage engine shutdown and then separation of the kick stage with its satellites, much like what was experienced for stage 1 and stage 2 separation. And we are less than 2 minutes away from the second stage's final actions.
HEV discharge holding nominal.
All right, and this is a 3D printed satellite. It is a technology demonstrator being...
Electron is powering through 1,900 kilometers an hour and rising, passing through 204 kilometers in altitude on its way to JAXA's final orbital altitude of 540 kilometers. Before we get to that, though, the second stage will deliver the kick stage and its payload to what's called a transfer orbit. This is an intermediate elliptical trajectory that's used to move the spacecraft into its final circular one. It acts like a bridge, with the kick stage using its engine to expand that transfer path and enter the final orbit for the mission.
All right, now as you heard, we are in the final stages after launch of igniting, sending off the kick stage, which will send
Okay, time is almost up now for Electron's second stage engine burn. And what will happen next is this. That Rutherford engine on your screen will be shut down by the rocket's flight computer, which will cause the nozzle to go from red hot to grey and cold. And within seconds of that shutdown, the kick stage will be separated from the second stage and released into its transfer orbit for the mission. Standing by now with Mission Control.
Well, so far this mission is going really well. Launch on time. Getting ready for...
Seeker
should
confirmed.
be very sure. There it is. The engine shut down. Everything seems to be running smooth
Stage
on this
separation
launch.
confirmed.
Nominal transfer orbit achieved.
There we go. That is SECO confirmed with the Rutherford engine shut down and the kick stage released from the second stage. Kakushin Rising is almost ready to be deployed to space to begin its mission. Once the kick stage completes its transfer orbit, it will ignite its engine to move out of that elliptical trajectory and into a circular one before the satellites are released.
Completing that elliptical path around Earth takes about 40 minutes or so, and so we'll be taking a break from the broadcast during that coast phase, but we will join you again live just before payload deployment of Kakushin Rising, which is scheduled to start at T plus 50 minutes into the mission. We'll see you back here then.
All right, folks, that probably will end that. We're getting ready for the separation in about 40 minutes, so we'll try to come back on that one. And we're working right now to get switched back over, hopefully, to the SpaceX launch, which is where we started off. And it looks like we are right now about 2 minutes out, so I'm going to be switching over to that. We can watch... the launch of SpaceX Starlink Group 17-14 out of Vandenberg Air Force Base in California. And let's head to Vandenberg. All right, guys, just give you a little recap here. This is Starlink Group 1714 launching from Vandenberg Air Force Base. That's Slick 4E.
Stage 2 LOX load is complete.
All right, we just finished up with LOX load, about 1 million pounds of propellant. And oxidizer on board. This is booster B1100, flight number 5 for this booster, 33-day turnaround. And this booster is scheduled to for an attempted recovery off the coast of California. On, of course, I Still Love You. This mission is carrying 24 version 2 Starlink satellites to orbit, low Earth orbit.
Falcon 9 is in startup.
All right, we are in startup now, and at this point, the onboard computers have taken over. Of course, there can always be a termination by ground control, but the rocket itself is autonomous and will, from this point forward, execute its mission profile.
T-minus 3 seconds.
And like I said, for those of you that came in towards the end, we just jumped in here. And due to the delay, switched over to the Kakushin rising Electron from RocketLab. And we'll probably switch back if we can. They're about 35 minutes from
2, 1. Ignition.
releasing their satellite. We have liftoff
SpaceX, go Starlink.
of Starlink Group 1714. Go SpaceX, go Starlink.
Vehicles pitching downrange.
M1.
Looks like we have all engines lit. Everything looks good so far.
Power and telemetry nominal.
All right, Falcon 9 looks to be running straight and hot. Did do its roll and is beginning its flight downrange.
Max Q.
And we just went through max Q, which you know is the point of maximum aerodynamic pressure placed on the vehicle. Before max Q, the vehicle pumps the brakes a little bit, and then will power back up once it goes through that point.
Stage 2 engine chill.
And we are chilling stage 2, so there's no shock to the pumps when stage 2 ignites. And we should be coming up shortly on first stage shutdown and then stage separation. And of course then stage 2 will take over the remainder of the work to orbit. Numbers all look good. Everything seems to be in line. Again, the next couple of events will be the first stage shutdown, stage SEP, ignition of the second stage, and the release of the fairings. A lot happens in a very short period of time. At that point in time, they will begin the process of stage 1 making its return trip back down to the recovery ship. Beautiful shot there. Just take a moment to thank, again, as we always do, SpaceX.
And back ignition.
MVAC has ignited. We're good. But thank you to SpaceX for what they provide. Same thing with RocketLab and the providers that all give us access to their feeds and let us share the amazing things they are doing in helping man become an interplanetary species.
Fairing separation confirmed.
Yeah, right. Fairings are gone. There are the satellites, 24 of them lined up. You'll see those grid fins that have just come up. Of course, those are used to help steer the ship and bring it down for a landing once the rocket comes down in and gets into the thicker parts of the atmosphere. Do no good outside. And of course, that's the cold gas thrusters that do the work there. But once they've reached the thicker parts of the atmosphere, those grid fins will steer the ship and bring it down, we hope, to landing number 5. You will see once the thicker part of the atmosphere is reached, those grid fins will start to glow a little bit. Those are amazing pieces. Speaking of pieces, I happen to be blessed enough. Had a piece of the grid fin from the very first landing gifted to me. Have that as part of my collection. Probably see it right behind me, over my left shoulder, your right side. And one of my prized possessions, to say the least. You see those bursts, those are the cold gas thrusters that are helping position the first stage, the Falcon 9, as it begins its return. Shouldn't be too long. You'll see the entry burn. Of course, that is the burn that will begin the process of slowing the Falcon 9 down as it makes its trip back to Earth. You only see 3 of the engines ignite for that burn. It's a very short duration burn, but does a lot. And then the final burn will be a single burn of the center engine as Falcon 9 makes its approach and lands on the drone ship. Beautiful shot looking up the Falcon 9. And also the second stage. Still burning hot, straight and steady. On its way to shortly down the road, releasing those 24 satellites to join the Starlink constellation. For those of you that have thought about Starlink, I recommend it very highly. I am an owner. I use it all the time. You can go out to Starship, to SpaceX, Starlink, and purchase the equipment. If you use the link on our page, you'll get yourself a little bit of free time once you purchase. And there is the burn we were waiting for. Fairly short burn. But the constellation is ever growing, and Dave Delivers Space uses it for remote launches, emergency situations. Living here in Florida, it's always good to have high-speed internet access for an emergency, and I would recommend it very highly. Again, I don't get a thing for it. We are not a monetized page. We do not have sponsors, although if there's anybody out there that would love to sponsor, we're always open to hear. And you see after that burn now the speed and the altitude is dropping off fairly fast. And we should just be a few moments away from the landing burn. And we hope recovery number 5 for this Falcon 9.
Stage 1 transonic.
All right. You heard that call. We just came through the sound speed of, through the sound barrier. I think Papa D needs a cup of coffee this evening. But that's when the grid fins will take over. Thicker part of the atmosphere will allow the grid fins to do their jobs and steer the ship down to a recovery. If you were out on the ocean right now on the West Coast, you would have heard a little sonic boom there.
Stage 1 landing burn.
And here's our burn. Should be seeing the drone ship come up.
Stage 2 terminal guidance.
Beautiful, beautiful shots.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
All right, there we go. 5th landing of this Falcon, and that would be Falcon Booster 1100. And that landed on, of course, I Still Love You, just off the coast of California.
Impact shutdown.
Just wait to hear if we got optimal orbit insertion.
Nominal orbit insertion.
There we go. And we are good to go. So that is another success for SpaceX. Congratulations to everyone out there. You guys do a great job. Amazing stuff. And we are looking forward to more and more as this year proceeds forward. There we go. But another successful launch and another one for the books. What we're going to do here for a bit, I'm going to be checking the time. We should be in the 20-plus minute range for the release of the Waseda Sat-Zero, nicknamed Kakushin Rising from RocketLab. So I will be switching back over, and we'll okay, there we go. Just a whole lot of things going on there, but let me switch over here, see if we still have a feed, which we should. Okay. All right. Let's see if we can do this with as little pain as possible. Okay, we're back on the feed for RocketLab. And again, for those of you that came in late, we initially intended just to initially show the Starlink launch and then switch over, but the Starlink launch was delayed, so that allowed me to continue the stream over here to RocketLab. And again, as we thank SpaceX, thank you to RocketLab for their amazing coverage and the things that they allow us to share with our viewers. But this is a technology demonstrator mission. It was manufactured by Waseda University, and the operator is Waseda University, going into sun-synchronous orbit, and it is a 3D printed satellite used to conduct experiments regarding deployment of various membrane surfaces. And it is, let's see, yeah, that's pretty much the nuts and bolts of what that is. The launch took place about 26 minutes ago. For those of you just coming in, you can back up through the feed, and both launches were covered. That's why we did a double header here. Normally we would have those separated and be separate streams, but technology being what it is allows us to switch back and forth pretty quick, as long as the providers don't mind us sharing their feeds. So we are thankful for that. Right now we're in coasting stage, and going to fast forward back through here, get us up to speed, up to date. All right, about that. Yeah, we've had feeds going back and forth, so we are getting close. But again, the spacecraft is in the coast stage prior to its release of the satellite. So what we're going to do is we're going to stay put with this for a while, and There we go. Bring myself up here a little bit. But we will stay with the coast feed here, finish this mission up, and hopefully be able to see an amazing view of the release of the Waseda Sat-02. And we should be within the 20-minute, 15-minute range right now. Okay. So what we will do, we'll just stand by here and watch together. If we get any additional information, the people at RocketLab have been keeping us updated with the status of the launch and the status of the payload. So we'll just stand by and stay with us, guys. Again, thank you to my subscribers. Thank you to new subscribers. If you are not yet a subscriber, please hit that subscribe button. Please share, like the videos. Every bit of it helps us immensely. We're just at the point now, after rebuilding the studio, after a major meltdown of equipment, we are back. And between this and the other page that I operate, the other channel, which is Let's Talk About It with Papa D, please feel free to check that out. There's a link on my page also. But we're back and running, and we're going to try to be really picking up the pace with the number of launches that are going to be going off here for the balance of the year. Big thing coming up, as you all know, we're getting ready for Starship to begin flying again. It's been a while. There's been rumors of 2 launches a month. That'll remain to be seen. We've got to get this next launch off, and the demonstration with respect to the in-orbit fueling. There's a lot of things that have to happen, looking at the NASA contract with the moon lander and all that. Again, we'll get more detail into that. I don't want to muddy too much the waters here with too many launches this evening. But be a lot going on for the rest of the year, and we look forward to sharing those with you. So for now, I'm going to stand by, and we will await, hopefully, a good deployment of the Waseda Sat-02, nicknamed Kakushin Rising. I'll be back. Enjoy. And thank you very much for coming out and spending some time with us tonight. Hey guys, Papa D back. Just wanted to stop in real quick, back in here. For those of you coming in late, we are in the midst of the final stages of the Kakushin Rising mission launched by RocketLab earlier this evening. It's been about 41 minutes since T0. Liftoff time was at approximately 11:09. This is a technology demonstrator satellite manufactured and operated by Waseda University. It's a technology demonstrator for 3D print satellites, and it will be used to conduct experiments and testing relating to membrane surfaces. So pretty exciting concept satellite using 3D printing technology. So pretty exciting. It's just a single payload tonight. Excuse me. A single payload, about 1.2 kilograms in weight. And we are expecting, I think we're down probably around 10 minutes or less of continuing the coast phase before the satellite is released into sun synchronous orbit. But launch did go off without a hitch. Electron, another amazing job for them, for that rocket. And I want to thank RocketLab for sharing all that footage and sharing these feeds with us so we can share these with you. Also, the reason we're carrying two tonight, like I said earlier, was that the SpaceX Starlink launch was delayed, and due to that delay, we were able to switch over to RocketLab and carry their launch as we're finishing up now. And if you want to go back and see the SpaceX launch, that's going to be there we go. Starlink. Okay, got it. But that launched out of Vandenberg Air Force Base. We did have a recovery. Went without a hitch out on the West Coast. So you can go back in the feed here. It's the same feed. I tied them all together rather than stop and restart and just confuse everything. So I ran them as a single packet with a double header. So you can go back and check that out. Please feel free to like, share, do all those things. All those things do help us get out a little bit further into the world of YouTube. Also, feel free to stop over to our other channel. My daughter Angela and I run. It's going to be Let's Talk About It with Papa D. We're streaming now both on our YouTube channel as well as our X channel on the X platform. So we'll be kicking that off here, new episode later this week, but please check it out. And again, if you're not a subscriber, hit that subscribe button. Doesn't cost anything. Does a whole lot of good to help us push the channel out there a little bit. We are not a monetized channel. What we do because we love it, and we do it for you guys. So those likes and shares and all those things, it's like getting a payday without the cash. But one day we hope to push it a little bit further. We're going to be a whole lot busier, as you know, with all the goings-on, both here on the Space Coast and out on the West Coast to some degree. So we're going to be hopping down here in Florida with all the new players and with all the big push for the moon and ultimately Mars, which has always been SpaceX's goal. So please like, share, and all that stuff. And again, we want to thank SpaceX and RocketLab both for all they do and all they allow us to do. We appreciate it. All right, guys, we'll switch back to RocketLab. We should be coming to a point at which they will be ready to release that satellite, and we can then conclude the broadcast. So stand by. Please enjoy. Continue to watch, and I'll be back shortly.
Hello and welcome back to our broadcast for the 87th Electron launch, the Kakushin Rising mission for JAXA. At 3:09 p.m. local time today, Electron left Earth with a beautiful looking launch from Launch Complex 1. After completing all of the usual milestones on the way to space, Electron separated its kick stage with JAXA's satellites to a temporary orbit around Earth.
After entering our transfer orbit 40 or so minutes ago, the kick stage is now ready to ignite its Curie engine to circularize to 540 kilometers. Let's go ahead and listen in.
Curie ignition confirmed.
And we just heard it there from Mission Control. Curie ignition is confirmed. This burn will last about a minute and a half, and then it's showtime for the payloads of Kakushin Rising. The payloads will be deployed at various intervals, and sometimes together, across the 3 minutes following Curie shutdown.
And if you've ever wondered what a Curie nozzle looks like, well, today is your lucky day because we have one here to show you. It's only 15 centimeters tall, but it packs quite the punch. And it's named after Polish-born French physicist Marie Curie, and it's responsible for our highly accurate payload deployment. Now, the Curie engine has a specific impulse of around 320 seconds, and like our other liquid propellant engines, it's majority 3D printed.
You may have picked up on a theme of our engine names. They're all named after groundbreaking physicists. Ernest Rutherford, Marie Curie, Archimedes of Syracuse, and now with our new ion thruster, we could add Carl Friedrich Gauss to the theme.
Otherwise, we are coming up on Curie cutoff very soon, so let's listen back in with Mission Control.
Curie cutoff confirmed. Nominal final orbit achieved.
There we go, straight from Mission Control, Curie cutoff confirmed. The first payload out will be FSI-SAT-2, a 1U CubeSat developed by the Future Science Institute as a low-cost satellite featuring a multispectral camera and onboard data processing system.
FSI-SAT-2 confirmed.
The space FSI-SAT-2.
Next up will be COSEN-2R, a 2U satellite developed between the National Institute of Technology, Yonago College, Gunma College, and other educational bodies. And it features a deployable antenna that will extend to study deformation of the Earth's crust below the sea floor. Let's listen in.
COSEN-2R, payload separation confirmed.
Nice one. That is COSEN-2R deployed to orbit to begin its mission.
Next up is a spacecraft called Prelude by Nihon University, a 6U nanosatellite created to detect earthquake precursors from space using VLF radio waves. Let's go, Prelude.
Payload Prelude separation confirmed.
Congratulations to the Nihon University team and JAXA, and welcome to orbit.
All right, two at once up next. The fourth payload is Mononiko, developed by Dainico Engineering Company, and it's an on-orbit demonstration of an intelligent power unit that can acquire status data from batteries installed on ultra-small spacecraft. And then payload number 5 is Magnaro 2 by Nagoya University. And their mission is to test a new method for constellation formations that involves rotating and separating linked microsatellites.
Payload Mononiko and Magnaro 2 separation confirmed.
5 out of 8 at their new homes. Welcome to space, Mononiko and Magnaro 2.
It's time for the final deployment for the final 3 spacecraft. First up is Arikatu by Aoyama Gakuin University testing a SATCOM network as an alert system for astronomical objects. Then we got Waseda Sat-02 by Waseda University, who used a molding technique to create their spacecraft with no screws or mechanical parts. And lastly, the Origami Sat-2 by the Institute of Science Tokyo. They'll be testing a lightweight and highly compact deployable antenna that's packed away using origami techniques, making it 25 times smaller when stowed.
Payload Origami Sat, payload WSZ2, and payload Arika2 separation confirmed.
Outstanding results there for JAXA's Kakushin Rising mission. Welcome to orbit, Arika 2, Waseda Sat-02, and Origami Sat-2. A marathon deployment there from Electron's kickstage. Just want to say congratulations to JAXA and all of its project partners for this latest mission of its innovative satellite technology demonstration program.
That is our second dedicated launch for JAXA, complete on Electron with 100% mission success. A proud moment for the team to support such an exciting mission full of interesting new technology. And that is also launch number 87 complete for Electron. So our next launch will be at the pad soon. Keep an eye out on our website and social media channels for details of those missions coming up. Otherwise, thank you so much for tuning into today's broadcast. Until next time, this is Rocket Lab Mission Control signing off.
All right, so we have cut that sound off there for you, but we have had a successful launch tonight for both SpaceX and RocketLab. As you saw, the primary payload and a number of ride-along satellites from that part of the JAXA launch, and they were successful on all 8. So congratulations. Give me a little volume here. There we go. But congratulations to both SpaceX and RocketLab this evening for 2 fantastic launches, highly successful. And please feel free to go back. You can rewind the tape, of course, on old school, but go back through the stream, and both those launches will be there for you to check out again or check out anytime. But with that, I think we'll call it a night. I want to thank you for coming out tonight and hanging out with Papa D. As you can tell, we were breaking in some new equipment and working out a couple of extra bugs, but things seem to be going good. And we had a exciting night with a couple of launches, a doubleheader night. So appreciate you coming out. Again, thank you to Rocket Lab, thank you to SpaceX, and thank you to everyone that works at those companies that continues to do amazing things every day. I'll be back with another launch, and I'm just checking my calendar so I can get you all up to speed. If you do hit that bell and you hit the subscribe button, you'll be notified when we go live at either one of the channels. But looks like we have a couple of long marches coming up. We won't be able to do much about that, but we do have a progress launch on Saturday at 6:21 p.m. and then another Starlink launch on Sunday the 26th. Another big one coming up. Please mark the calendar for this. If you hit the bell, you'll be notified. We do have a Falcon Heavy launch, a Viasat, going off on April 27th. That is a Monday at 10:21 a.m. That is the first Falcon Heavy that has gone off in quite a while. So we'll get a little bit deeper into that. That's going to be an amazing show. And then we'll have some Amazon stuff coming up, but we'll get into that. But again, thank you guys. I appreciate you coming out, spending some time with Papa D. Please subscribe, please hit like, please share, please do all them cool things. It helps us grow. And maybe one day we'll get a chance to start meeting some of you folks, because we are doing some remote stuff. So but let us know. Drop us a comment. Let you know where you are, who you are, and maybe we can get together and check a launch out together. But with that, I will say good night, and thanks again to all of our amazing subscribers and amazing, hopefully, new subscribers. So with that, I will say good evening and have a good night.